Okay, now let's go to the definition. Okay, let's see the lesson overview and the lesson objectives. In this lesson, we shall be looking at the following definition of heat, the sources of heat and the types of heat we have, and hot heat transfer, and the methods of heat transfer and the rest, okay? And at the end of this lesson, the student should be able to know the meaning of heat, also to know the sources and types of heat. You should be able to know that. The third one, to know the methods of hot heat transfer, and also to know how to the construction of the vacuum flask and how it prevents hot heat loss. You should be able to know these hot four things over there. Okay. Now let's look at the definition of heat. Heat refers to the amount of thermal energy contained in the body. Heat refers to the amount of thermal energy contained in the body, or is produced as a result of temperature difference between two bodies that are in contact. Due to the temperature difference between two bodies that are in contact. What happens is that whenever there is temperature difference, that's when you can feel heat. Yeah. Let's say if I have two bodies, one is at a temperature of 50 degrees Celsius, and I have another body which is my nose mass over here. It's at a temperature of, let's say, 20 degrees Celsius. What happens is that there's going to be temperature or transfer from the higher temperature region to the lower. So if I connect the two, you see that the one with the lower temperature becomes hot, very hot, because it heat hot is being transferred from hot, the higher temperature region, to hot, the lower hot temperature hot region. So heat always flows from a higher point to hot, a lower point, or a higher temperature region to hot, a lower hot temperature region. And heat can only be transferred when there is hot, a temperature hot difference. That means if I have two bodies that, let's say, all of them are having the same amount of heat. Let's say this one is having 50 degrees Celsius. This one is also 50 degrees Celsius. If I connect the two, there cannot be hot heat transfer because both are hot, having the same hot temperature. But the moment I have a temperature difference, let's say one is hot higher than the other, heat can be hot transferred. Heat can be transferred. Okay, so let me just read. If two bodies are in contact and they have different temperatures, heat flows from the higher temperature region to the region of lower temperature. That's what I was explaining. So heat moves always moves from hot a higher temperature region to hot a lower hot temperature hot region. Heat can never flow if temperature of the bodies in contact are the same. So if you have temperature of the two bodies which are hot the same, heat can never flow. Heat can never flow. So there must be difference in hot temperature for heat to hot flow. And when substances, sorry, so when a substance is heated, the particles get excited and move faster, which increases hot the temperature. If um, if you heat a solid material, you know that a solid, the particles are closely hot packed. In solid, let me demonstrate something to you right now. In solid, the particles are closely packed. Since they are closely packed, let's say this is one particle, this is another particle. In the solid, they are closely packed. So if this particle receive heat, since it's hot, closely attached to this can also hot receive the heat easily. So since they are closely packed, there's going to be transmission of heat through hot the particles, or even if they are hot spaced. Let's say the particles are hot spaced. Let's say it's a liquid. When you heat liquid for a very long time, it becomes very hot, right? So the liquid, the particles are a bit hot spaced. Okay. So if let's say you heat and this particle receives the heat, this particle becomes hot excited. When it becomes excited, it's just like if you eat food right now, you gain energy to what to move about. So when this particle receives heat, is the food it gains, so it begins to what move. It gets excited and begin to move. When this gets excited, it moves and what collide with what this. So the particles collide with what each other. When it collide with this also get excited, move and collide with another particle. So you see that the collision of the particles produces what heat. The collision of the particles produces heat. We say friction hot produces hot heat. Is that also? Yeah. So that's basically hot. Hot over there. When a substance is heated, the particles get excited and move faster, which increases hot the temperature. So the particles, when they get excited, they move faster and collide with other particles within the same region and hot. When a collision occurs, there's going to be hot, heat hot, which will be hot produced. And since heat is a form of energy, the unit for heat is what joules, as you can see over there. The unit of measurement of heat is what joules. And the instrument we use to measure heat, we call that instrument what the calorimeter. Calorimeter. So this is just a brief uh, definition of what heat. Heat can only be transferred when there is a temperature difference. Note that first. Whenever there is a, let's say, the two bodies are having the same temperature, there can never be hot heat transfer. There must always be a temperature difference for heat to hot flow. And also, when you heat a material, the particles hot get excited and collide with other particles in the confound hot region. When they collide with other particles, the collision produces hot heat because there's going to be friction. So friction occurs, there's going to be heat produced. So that's how come heat energy. That's what I have briefly about heat energy for you. Yeah. So that's the definition for heat, and we have the sources of heat. Um, we have the solar energy from the sun. Solar energy from the sun. Okay. Uh, the solar energy that's from the sun reaches the solar panel by hot radiation. If we talk about radiation, that means hot. There is no hot medium of hot transfer. There is no particle or medium of hot heat transfer. So there is no hot neighboring particle hot transferring the heat onto hot the solar panel. So if the solar panels you see, let's say some they use it for our street light, and so they receive hot heat energy from hot the sun. That heat energy is used to excite the electrons, which helps us generate electricity. So the heat energy excites the electrons on the solar hot panel. Okay, I just mentioned that if you hit a particle right now, it collides with other particles. They get excited and collide with other particles. So heat energy from the sun, when it hits the solar panel, what happens is that it excites the electrons on the solar panel, which helps the electrons to begin to move. And the movement of electrons in the conductor, that brings about the electricity. Movement of electrons in a conductor or a conducting material, that's what brings about the electricity. And another source of heat is electricity. Uh, for example, let's say the normal electricity in your house, which is being gotten from the hydroelectric dam. Okay, the dam as Akosombo. That electricity you use it for ironing hot your clothes. Use it for heating water by the use of the kettle and things. Okay, so it's a source of heat. It's a source of heat. Okay, another one is the friction. You know, friction is uh, the opposing force, whereby one body prevents the other from moving smoothly on it, and it only occurs when two bodies come into contact. When bodies come into contact with each other, and one is moving on the other, but The other body is preventing hot. Uh, the other body is preventing the one that is hot moving hot from moving hot smoothly. So when two bodies come into contact and hot, they are in hot motion on which each other, what happens is that there's going to be hot friction. We call that hot friction. And you know, when you rub your palm for a very long time, you see that there is heat that will be hot produced. So it's a source of hot heat when two bodies collide with each other. An example is when rocks, okay, when rocks hit each other, there's going to be hot. Or if you use a rock to hit another rock, what happens? You see a sparkle of hot light. Yeah, and so we can say that hot collision when two bodies come into contact, there's we call that hot, let's say collision. Okay, if they collide, there's hot friction, and friction hot produces hot heat. Friction is a source of hot heat. Chemical reactions also are sources of heat. In your laboratory, if you mix some chemicals, you see that they begin to boil, right? They emit heat. I don't know much about it, but if you go to your chemistry lab and you perform certain experiment, you see that heat is being hot, emitted into the environment. Whenever heat is emitted into the environment, we call it the exothermic reaction, like it okay to the outer or surrounding. But when heat is hot, being given to the inside hot or surrounding, we call it endothermic reaction. So during these reactions, heat hot is being hot produced. So chemical reaction also is also one source of hot heat. And we have the nuclear reactions, you know, the nuclear fission and the nuclear fusion. And you know, if they want to manufacture this weapon, uh, the the bomb and the rest, all they are all hot nuclear hot reactions. Okay, they are nuclear reactions that take place when they are being hot manufactured, and these all are hot sources of hot heat. Another one is the fire at home, fire, the fire you light. All those are sources of heat. And another one is called the geothermal energy. I know you know all these things. That's why I'm rushing through. Okay, geothermal energy. Anytime you hear geo means for the earth. Geo means the earth. So thermal attached to it, that means what heat from hot the earth. I mentioned this hot the previous time when we were looking at hot the forms of hot energy. So the geothermal energy is hot the heat from the earth. You know, rocks slide over hot each other. Uh, okay, when rocks slide over each other, there's going to be hot heat that will be produced beneath hot the earth. Okay, so that heat is sort a source of heat. Sometimes they use it in generation of hot electricity. Okay, when heat is being produced like that, it's used to hot 10 turbine, uh, which is used to hot generate hot electricity for our homes or industries. So these are basically the sources of heat that we have: the solar, the electricity. We have more. Okay, we have the friction, chemical reaction, nuclear reactions, fire, and hot the geothermal. These just a few that I've mentioned over here. If you if you if you're on your own, then you just make some research more on the sources of hot heat. Let's look at the effect of heat. So the sources we are on hot, the effect of heat. Heat can change the state of a body. If we talk about the state of a body, we are talking about either the liquid state, the solid state, or the gaseous state. Sometimes when you apply excessive heat to water, what happens is that it changes its state to hot, the vapor hot state, okay, or the gaseous state. It evaporizes. So you can say there's a change in state. What causes that change in state is what the excessive heat produced or the excessive heat applied to hot that water. So heat can change the state of hot and body. Sometimes it changes its state from hot solid to hot, let's say the gaseous state. That's the naphthalene bulb. So, or it can change its state from hot, the gaseous state to hot, the liquid hot state. So heat can cause change in state of hot a body. It can cause change in state of a body. if you are heating a water in a pot, what happens is that you see when you cover it, after some time you see that the water evaporates, and or you see the steam of water uh, lying on the surface of the lid. Okay, so that stream of water, you see that the vapor hot condenses back into hot liquid, and hot causes that is the liquid first of all vaporizes, and hot settles at the top of all the lid, and hot it condenses back. Okay, when the source of heat is hot being removed, or when it is cooling, it hot condenses back. So this hot change in state. There's heat that's been applied to it. There's change in hot temperature. Okay, so the second one over there is hot. Heat can change the temperature of a body. You remember the temperature is different from what the state. I said state is from what, let's say solid to liquid, liquid to gas, or gas to hot solid, any one of them. Okay, but if you say heat can change the temperature of a body, let's say if you have water and you heat it, automatically the water is going to, or the temperature of the water is going to rise. Okay, when it begins to boil, that's when the water reaches a temperature of 100 degrees Celsius. You see that the temperature of the water has sort changed. The temperature of the water has sort changed. So for a liquid to boil, you must change the temperature of what the liquid. So heat being applied to that liquid at that moment is the one causing or the change in hot the temperature for the liquid. For example, in if you go out of your room, let's say the sun is very hot, the temperature of your body hot changes. You because hot, you are receiving heat from hot the sun. Are receiving heat from hot the sun. Why do you receive the heat from the sun? First of all, your body was cold, and I told you that heat moves from a higher temperature region to hot a lower hot temperature region. So heat from the sun is at a higher temperature region. Your body is hot of a lower temperature region. So heat moves into your body. So you see that your temperature begins to hot change. Okay. When you go to, let's say, places like Russia, when the weather is very cold and the temperature is very low. So what happens when you move out of your room? You see that hot, heat in your body is being donated to the surroundings. So your body, inside your body, you feel hot, cold. You feel very hot, cold. Okay. So that's one. Heat can change the temperature of a body. Or you can put, let's say, a metallic substance under the sun for a very long time. You see that it becomes very hot, hot. The temperature will automatically change. And heat affects what the chemical composition of what a body. The chemical composition of a body. You know, in our bodies or in anybody, there's going to be hot chemical hot reaction. And I just told you that whenever you heat a material, particles get excited, or the chemicals begin to react with each other. So it will affect the chemical composition. Okay, it will affect the chemical composition because the state of the body will automatically change. If the state changes, the chemical composition of the body will also change. Okay, and if you come to the fourth one, heat causes expansion and contraction of a body. Expansion or contraction, if you take your roofing sheet, for example, you see that if you take your roofing sheet, for example, you see that when you are getting, let's say the sun is very hot, your roofing sheet expands. But in the evening, thereabout, it hot contracts. When note this, when heat is applied, excessive heat is applied to a material, maybe metals, what happens is that they expand. But when that metal is subjected to hot cooling, it hot contracts. So the expansion and the contraction of your roofing sheet is what makes that sound. Sometimes you hear crack, crack, crack. Okay, is the expansion and contraction of what your roofing sheet. So heat also hot causes expansion and contraction, and it causes expansion when there is excessive heat being produced, and causes contraction when let's say the body is subjected to hot cooling, it hot contracts. When it's cooling, it contracts. When excessive heat is applied, it hot expands. So that's another effect of hot heat. Another effect of heat. And another one I thought heat can change the electrical conductivity and resistivity of hot conductor. Heat can change the electrical conductivity and resistivity of hot conductor. I mentioned that anytime you apply heat to a metal, uh, the molecules, or let's say the particles, get hot excited and they begin to move and collide with hot neighboring hot particles, or they begin to move and collide with hot neighboring hot particles, or they transmit uh, the heat to the neighboring hot particles. And you know that you heat if you heat a material right now, what happens if the particles get excited? They begin to hot move. They begin to hot move, and the movement of electrons. Let's say my particle is an hot electron, okay, and if let's say you heat you hit a material right now, the electrons get excited, or you hit a metal, electrons get excited. When they get excited, what happens is that they begin to hot move, and the movement of electrons is what produces hot electricity. The movement of electrons is what hot produces hot electricity. So let's say when you heat a material to hot a very high temperature, the particles inside begin to hot move. They get excited, and when they begin to move, they collide with neighboring particles, and the movement of those particles, let's say the electron per se, is hot produces hot called hot electricity. So heat can change the electrical conductivity and hot resistivity of hot a conductor of a conductor. Any question up to this point? Hello, are you guys hearing me?
Yes, sir.
Yes, sir, we can hear you.
You understand what I'm?
You're too quiet.
You say?
Yes, sir.
So is it because you are quiet?
You understand?
Yes, sir, we understand.
Okay, okay. Thank you.
Yes, sir, we understand.
All right. So basically, these are mute yourself. Okay. Basically, these are the effects of what heat that we have. Now, let's look at the types of heat. The types of heat. Basically, we have two types of heat. We have two types of heat. We have the sensible heat and the latent hot heat. Sensible heat and the latent heat. When we talk about sensible heat, this is the type of heat energy which, when supplied to a body, causes change in temperature of the body without changing the state. Okay, it causes change in temperature of the body without changing the state. If you boil a water right now, without the water reaching hot 100 degrees Celsius or above, or let's say a little bit above 100 degrees, what happens is that the water cannot reach its hot vapor state. Okay, but when you heat water above 100 degrees, that means it has bypassed its boiling hot point, so it begins to hot vaporize. It begins to hot vaporize. Now, before I come to that scenario, we said hot. This is the type of heat energy which, when supplied to a body, causes change in temperature of the body without changing the state. So if you heat water, let's say, to a temperature of about 70 degrees Celsius, the state of the water will still be the same. It will not vaporize at that point, unless it is hot above the 100 degrees Celsius. So let's say we heat water to about 70 degrees Celsius. The temperature, the water will be hot, but it will not vaporize at that point. So let's say the temperature of the water changes but the state of the water will still be hot, the same. The temperature of the water will change, but the state will still hot, be the same. The state will still be the same. So when it happens like this, we call it a sensible heat. Sensible heat, okay? The example I've given over there, when heat is applied to an ion, the temperature changes, but sorry, there is a mistake there. But the ion will still remain in its hot, solid hot state. But it will still remain in its hot, solid hot state. That means when you heat an ion, okay, a piece of metal, let's say an iron, when you heat it, what happens is that it will get hot, heated. It becomes very hot, but it doesn't change its state from hot. It doesn't change its state from, let's say, the solid to hot, liquid or gas. It will still be hot, solid. You take any piece of metal that can withstand high amount of heat and put it, let's say, apply excessive heat to it. You see that the metal gets heated, but the state doesn't change. It still remains to be hot, solid. The state doesn't change. So this, we call it a sensible hot heat. Sensible heat. Then we have another one we call hot, the latent hot heat. Latent heat. And this is a type of heat energy which, when supplied to a body, causes change in state of a body without changing its hot temperature. So it just vice versa for the, or just the opposite of a sensible hot heat. This one is hot. This is a type of heat energy which, when supplied to a body, causes change in state without changing its hot temperature. So this one, the state changes, but the temperature remains the same. The temperature remains the same. If heat is supplied to a body and changes, or let's say, if the heat supplied to a body will change its state from hot solid to hot liquid without changing hot temperature, we have two types of latent heat. We have the latent heat of fusion and we have the latent heat of vaporization. Anytime you hear vaporization, you know that liquid is hot involved. So when we talk about the latent heat of when we talk about latent heat of let's say fusion, that one we are dealing with a solid. So note the difference. Latent heat of fusion deals with solid. Latent heat of vaporization deals with liquid. Okay. Now let me go over. If heat is applied to a body, if the heat supplied to a body will change its state from hot solid to hot liquid without changing temperature, it is called
Sir,
the latent heat. Yeah.
the statement you made right now, I didn't get it because my network shifted.
Yeah. What I'm saying is, when we talk about latent heat of fusion, we are dealing with, anytime here latent heat of fusion, it deals with our solid figures. Okay. That's from solid to hot liquid. Okay, or solid to liquid. But whenever we hear vaporization, that means you are dealing with hot liquid. We are dealing with hot liquid. So latent heat of vaporization deals with hot liquid. Latent heat of hot fusion deals with hot solid. Okay, so that's what I was saying. So yeah, let me read over again. If the heat supplied to a body will change its state from hot solid to hot liquid without change in temperature, it's called hot latent heat of hot fusion. Latent heat of fusion. Okay. So if you apply heat to a substance and it changes its state from hot solid to hot liquid without change in temperature, without a change in temperature, we call it hot latent heat of hot fusion. Note, if you are defining this, you see that at the end I bring without change in temperature. that must be included in your definition always. That's why the fusion is having that. And if you are reading the latent heat of vaporization also, it's also having the same statement without changing hot temperature. Make sure you include that in your hot definition anytime you are defining hot latent heat of hot fusion and latent heat of vaporization. That one, the temperature doesn't change. But if you come to the fusion, it's from hot the solid state to what the liquid state without changing temperature. Then if you come to the latent heat of vaporization, it's from the liquid state to what the vapor state without changing hot temperature. In certain books, you can also see from the vapor state to the liquid state is the same thing. All of them is vice versa. Okay. So someone can also say latent heat of a fusion is when heat is applied and it changes its state. It changes the state of a body from liquid to hot solid without changing temperature. It's also correct. It can be liquid to solid or solid to hot liquid. Make sure the solid is there. And if you come to latent heat of hot vaporization, is from hot liquid to hot vapor or from vapor to liquid without hot changing hot temperature. So that's it about latent heat of hot fusion and latent heat of hot vaporization. So with this explanation, give me or state the difference between the latent heat and the sensible heat. Latent heat and sensible heat with what I just said. Just give me briefly the difference between latent heat and hot sensible hot heat. Yes, if you know it, just raise your hand. Let's see. Yeah, nobody. Ganyo Princess.
Yes, sir.
Yeah. Give us one difference between the latent heat and the sensible heat. Okay, there is a hand raised. Kamasa. Kamasa.
Sir,
Yeah.
sir, sensible heat does not change the state of the body, but latent heat changes the state of the body.
That's very good. So you say latent heat out, the state of changes, but sensible heat, the state doesn't hot change. That's good. So that's basically the difference between hot, the latent heat and that of hot, the sensible hot heat, the latent heat and the sensible heat. Let's look at heat transfer. If we talk about transfer, that means movement from hot one place to hot the other. That means you are moving one material from hot one place to hot the other. So if we talk about heat transfer, that means we are moving heat from hot one place to the other, or yeah, the movement of heat from one place to hot the other. So heat transfer refers to the process by which
Sir.
heat is, yeah.
So can you also give one difference between sensible heat and latent heat, as the sensible heat, there's a change in temperature, and the latent heat,
Yeah,
there
it's
is
also
no
correct.
change in temperature.
Yeah, it's also correct.
Okay.
So you use the state and the temperature in giving her the differences. Thank you.
Okay.
Right. So when we talk about heat transfer refers to what the process by which heat is moved from one point to what the another to another. So when you move heat from one point to the another, we call it hot heat hot transfer. Okay. So heat can only be transferred from one point to another if there is a temperature difference between the 2 points. I made mention of that. Okay, I made mention of that. So let me demonstrate that again. I apply 50, let's say he is having a temperature of 0 degrees Celsius. Okay. Okay. And I apply a temperature over here, which is at 5 degrees Celsius. Here will still be 0 because I didn't apply any heat at this point. But here it's at 5. So heat will move from what? The 5 and transmit it equally to what? Where is what? We have what? The 0 degrees Celsius. So heat will be moved from what? A higher temperature region to the lower temperature region. So there's going to be hot heat transfer. And we have 3 main ways by which you can transfer heat from one point to another. We have the conduction, the convection, and the radiation. You have the conduction, convection, and the radiation. Okay. What happens is that conduction, as you can see, this refers to the transfer of heat through a material from a place of higher temperature region to a place of lower temperature region without the molecules of the particle moving as a whole. You know, conduction mainly occurs in hot solids. Okay, solids, the particles are closely hot packed. So without even the particles of solids moving, heat can be hot transferred. It's just like if I'm hot and you touch my body, you also feel the same hotness, like you feel the heat within you. So since the solids, the particles are closely packed, if this one receives heat, this one is hot closely attached to it. So this also hot receives heat from this. If another body is connected, you see that the heat will be hot transferred hot equally. So that's how conduction hot takes place. The material does not move as a whole, but there is heat hot transferred from a higher temperature region to a region of lower hot temperature, to a region of lower hot temperature. So that's basically what happens in hot conduction. So that's one method of heat hot transfer. That's one method of heat transfer. So it refers to the transfer. Let me go over the transfer of heat through a material medium from one place of a higher temperature to a place of lower hot temperature. A higher temperature to a lower temperature without the material moving as a whole. Make sure that is included in your definition. Without the material moving as a whole. So that means the material can be hot, they are closely hot packed, and conduction mainly occurs in solids. Okay, like metals like this. The particles are closely hot packed. They are closely hot packed. You know the particle arrangement of each solid, liquid, and hot gas. In solids, the particles are closely packed, and that means they are connected to each other. So that means if one gets hot, the neighboring particle also receive the same hotness and transfer it to the subsequent hot, or they are neighboring hot particles. Okay. And with all that I've said, let's just go through these questions and see how does conduction take place in solids. I just explained that. I just explained the first one. How does conduction take place in solids? Conduction takes place in solid because the particles of solid are hot, closely packed. And since they are closely packed, if heat is being subjected to one particle, the neighboring particles also receive the same heat. The neighboring particles also receive, because they are closely packed, they are connected towards each other. So that's how come conduction take place in solids. And what's a good conductor of heat? A good conductor of heat. Can someone tell me what's a good conductor of heat? If we say good conductor of heat, just raise your hand, let me call you. Just don't be shy. Hello. Joseph Kumantu. Okay, I have someone here. Sorry, Kamasa Victor. Kamasa.
Said still.
Is that?
I said still.
I didn't say she give me an example of good conductors. Like hot is a good conductor of it. The definition hot's a good conductor of it. That's what I'm asking. You know, a good conductor of heat, there are materials that easily allow heat to flow through. Okay. Uh, the ones that are not good conductors of heat are the ones that we call, let's say, insulators. Insulators. That's why you have your cooking utensils. There is a wooden structure on it so that if maybe you want to lift it, you can. If it's very hot, you just hold the wood or the wooden part because that place is a poor conductor of heat or a bad conductor of heat. So a good conductor of heat basically is a material which easily which allows hot heat to flow through it easily. Okay, without any difficulty. Without any difficulty. So go and research on the experiment to show how to show conduction of hot heat. Go and research on it. So basically, a good conductor is the one that allows heat to readily flow through without any difficulty. And bad conductor of heat is the one that don't allow heat to flow through heat easily. And let's move to convection. Okay. I'm coming. So convection is a transfer of heat from one place to another by the movement of the hot body carrying the heat itself due to hot difference in hot temperature. Due to difference in hot temperature. When you heat a water, let's say you heat a water in let's say a silver, what happens is that I note this: if temperature increases, the density of the substance also has. If you increase the temperature of a substance right now, the density of that substance will also decrease. So when temperature increases, density reduces. Okay. So when you heat a water, the bottom of the water that has been heated, the density at the bottom becomes very hot, light, like it has a lower hot. Because the temperature increase at the bottom, there's going to be lower in the density will be less as compared to the top. So the top become higher dense than the bottom. So the higher dense displaces the lower dense because here the down now the bonds are being broken, so it becomes lower dense. So it moves to the top. It becomes lighter, so it moves to the top, and the higher dense moves to the bottom. So basically, that's how convection also takes place. We said this is a transfer of heat from one place to another by the movement of the hot body carrying the heat itself due to the temperature difference. Due to temperature difference. So let's say you have you are boiling So you are boiling, let's say, let me make this example. Mm, let's say you have your garden egg, you are boiling it. Sometimes you see that it hot moves up and hot comes down, those kind of things, those reactions, right? What happens is that when excessive heat is applied, uh, it becomes hot, less dense, so it has to displace the higher dense, which is the water at the top. So it moves up and hot. The higher dense part moves hot down. The higher dense water hot moves down, as I was demonstrating. Okay. Sometimes when you are boiling, say you are preparing your soup, you see that some of the ingredients that you use, let's say the stuffs that you'll be using in cooking, garden egg, those kind of things, you see them hot floating on the surface. You see them floating on the surface. Okay, or the meats, they float on the surface. As soon as you heat it, they become less dense, so they have to hot float. They become less dense, so they have to hot float on the surface. And the surface that was hot, very high dense, when you started heating hot, most hot, the bottom. So that's how convection takes place. This one, there is hot movement of hot particles. But in conduction, there is no hot movement hot particles. The particles doesn't move as a whole. But this one, there is hot movement of hot the particles itself. Because let's say you take a liquid right now, the particles are hot a bit space, so they get excited and begin to hot move and collide with hot each other. And convection normally takes place in hot liquid. It normally takes place in hot liquids. So this one, there is a movement of hot particles, and in conduction, there is no movement of hot particles. Note the difference between the two. Note the difference between the two. And I mentioned that if temperature increases, the density hot decreases. So if the density decreases, what happens is that I record. If the density decreases, it displaces the higher dense one. So the higher dense moves to the bottom, the less dense hot moves to the top. The less dense moves to the top. Now, that's how the convection occur. Who is that? Um, so radiation. When we come to radiation, this is the transfer of heat energy from one place to another without any material hot medium. Without any material medium. I told you an example is the solar. The solar radiation from what? The sun. The solar radiation from the sun. Okay. And if, let's say, this one, there is no movement of hot particle or any there's no material medium for the sun rays to be hot, to heat hot, that of the solar hot, the solar panel. You see that in convection, that one, there is a movement of particles. Okay, the particles collide with each other when it's being hot. Let's say you heat hot the liquid, the particles or they collide with each other, which brings about a heat in the system. But in solar, that one, the sun rays or the heat or the solar panels, there is no material medium. We cannot say, okay, these particles move and heat this. No, but there is a transfer of heat directly onto the solar panels without any material medium, without any material medium, or without any particle heating hot the other. No, that one is the result a direct contact to hot with heat. Okay, there is direct contact. There is hot heat transfer. No particles are hot colliding. No, there is hot heat, just heat transfer. So that's hot radiation. Radiation, there is no material medium in hot radiation. There is no material medium in hot radiation. Okay, but in conduction, there is a material medium, but the materials doesn't move as a whole. The particles don't move as a whole. In convection, there is movement of particles. There is what the particles are involved. But in radiation, there is no particle hot at all. Okay, so unlike conduction and convection, this mode of heat transfer does not require any hot material medium for heat to be transferred. For the heat to be transferred, they don't require any particle or any material medium for the heat to be transferred. It does not involve the movement of particles or contact between hot particles. An example is the solar hot radiation hot from the sun. The solar radiation from the sun. Okay. When you come, I'll show you one. I'll send you to my house to see one. Okay. So we are now moving to the vacuum flask. The vacuum flask is basically it's used to store, let's say, cold water to maintain the temperature of a cold water being poured into it, or to maintain the temperature of a hot water being poured into it. So let's say if you pour a hot water into a vacuum flask, what happens is that it will maintain that temperature for a very long period of time. Okay, it will maintain that temperature for you for a very long period of time. And when you pour cold water into it also, it maintains the same temperature for you for a very long period of time. So that's basically the use of the vacuum hot flask. It's used to store cold water or hot water. Why is it used to store it? Because it maintains the temperature region of that cold or hot water for a very long period of time. Yeah, Amujuno, Priska. 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 Yes.
Sir,
I'm not hearing you. I saw your hand raised, that's why I called you.
sir,
Yes.
sir, please, I can't hear you.
You can't hear me. What I'm saying is the vacuum flask you have over there is used to maintain the temperature of the water placed into it. Whether it's being the water is cold or hot, it maintains that temperature region for a very long period of time. Okay. I'm not saying if you pour hot water inside 10 years time it will still be hot. No. As time goes, like the temperature of hot decreases. So let's say you want to prepare some tea and you pour hot water into the vacuum flask. What happens is that in 30 minutes time, you still have the same amount of hot temperature region. Let's say you still have your water to be hot for your tea. So the vacuum flask basically is used to maintain the temperature of the water being stored into it. So when you pour hot water into it, it maintains that temperature for a very long time before losing its temperature. Okay. When you pour cold water into it, it still maintains the same hot temperature region. So either hot or cold, it maintains the temperature. And it's having some basic features that helps it to maintain this temperature. It has some basic features or some parts which are very essential in its hot construction. Okay, so as you can see in the diagram over there, we have the plastic stopper. There is a reason for it over there. We have the double walled metal or plastic hot container. There is a reason for it over there. So all the parts you have on this vacuum flask you are seeing on your screen, they are all having their importance. Okay, they are not just there. The vacuum created over there, as you can see in your diagram, is having its own hot function over there. The silver surface double glass ball is also having its own function. Then the insulated support also is also having its own hot function in maintaining the temperature of the system. So now let's move to the importance of the various hot parts. Why the vacuum flask is being constructed in this manner. Let's see. Uh, in some books, you see thermos flask is the same as for the vacuum flask. The thermos hot flask, thermos likes a temperature, okay, or heat. It's usually used for hot. You know, if we say thermodynamics, we are dealing with hot heat. To anything thermo, we are talking about hot heat. To thermos hot flask, thermos flask. So the vacuum flask is also known as the thermos hot flask. It's used to store cold hot liquid. Now let's look at the function of the parts of a vacuum hot flask. The first one over there is the silvered and the shiny surface of the glass hot prevent heat loss by radiation. It prevents heat loss by radiation. What happens is that the solar panel, I said, it receives heat from the sun through let's say radiation. What happens is that when the sun rays hot heat hot the solar panel absorbs all the heat. But here lies the case. This one in our vacuum flask, we said is having a silvered and a shiny hot surface. So because of the silver and the shiny over there, anytime it receives heat, it reflects the heat back into the system. It doesn't absorb the heat, it reflects it back into the system. Okay, it's just like this is our shiny surface. If you apply heat to heat let's say this shiny surface over here, it's not going to absorb the heat, it's what reflects the heat back into the system. Okay, so you see that it maintains this helps maintain the temperature of the water, or keep the temperature of the water. And so that's one. The silver surface prevents heat loss by hot radiation. That's they reflect heat back into the system. You know, if you pour water into let's say that flask right now, the water gets evaporated. When it gets evaporated, there is heat being released into the system. When that heat hits the surface, the shiny surface is being brought back into the system. It doesn't absorb. The shiny surface does not absorb the heat. It reflects the heat back into the system, which maintains the temperature of the water. Okay. The second one over there is the cork support. You know that cork is an hot insulator. Cork is an insulator, so it does not allow heat to flow through it. So the cork support, as you can see in your diagram, let's go back to the diagram. The cork support is the same as for the insulated support, because the cork is an hot insulator. So heat cannot flow to the outer surrounding because the cork support is there. So when let's say the walls even get heated, heat can never get to the outer walls. The insulated support is the separation between the inner walls and out of the outer walls. So to prevent heat transfer from the inner walls to the outer walls, we have the cork support over there to prevent heat transfer to the outer surrounding. Okay, so since cork is poor conductor of heat or an insulator, we use it so that it separates the inner wall from the outer wall. So to prevent heat transfer from the inner to the outer part of the vacuum hot flask. And the third one we have over there is the vacuum between The double was reduces hot heat loss by hot conduction and hot convection. We said conduction takes place when there is material medium in hot conduction as well as hot convection. I made mention of that. But in conduction, I said material does not move as a whole. But in convection, there is a movement of the materials, right? So we have a vacuum over there. As you can see in the diagram, the vacuum over there, since hot vacuum means hot, there is no air, nothing is present. Vacuum, just an empty hot space. There is no air over there. So since there is no air, that means there is absence of hot particles at that region. So there cannot be heat transfer. No particle is in contact. There is no particle there to move and collide with the other hot particle. So since there is no contact or between particles and there is absence of particles over there is no heat transfer by hot conduction or convection. There can never be hot heat transfer by conduction or hot convection. Any question? Jamisi,
Sir.
are you getting it?
Yes, sir. I'm following.
Oh, okay. Thank you.
Okay.
So that's the function of the various parts of the vacuum flask. Okay, even you can see that there is a plastic hot stopper. It's not made of hot metal, it's hot plastic. Okay, and that plastic stopper is hot an insulator. It's a poor conductor of hot heat. Before heat gets to the outer surrounding, it takes a very long time. Poor insulators take very long time before heat can, let's say, penetrate through. You know, that's why if you the handle of your, let's say, cooking utensils, after some time it also gets hot. When you heat, apply excessive heat. That's when you apply excessive heat to it. So this plastic stopper also is what, let's say, an insulator. That's why I said you cannot keep water into the inside this vacuum flask for a very long period of time, because when it becomes, let's say, if you keep water inside for a very long period of time, let's say from morning to evening, what happens is that the plastic stopper also gets hot, and hot heat is being dissipated toward the surrounding. Okay, but let's say if you want to use it for a very short period of time, you want to prepare tea, you want to maintain the temperature of the water within a short period of time, you can use the vacuum flask. Okay, and at that time the plastic stopper will prevent heat hot from flowing from the inner to the outer hot surrounding, from the inner to the outer surrounding. So so this is basically questions to answer under what we've just treated. Draw and label the vacuum flask. So the vacuum flask, as you've seen over there, you have to learn how to draw it and label the various parts, and also be able to explain how uh, heat losses are minimized in a vacuum flask. So if you take a vacuum flask, for example, how heat can be minimized using the vacuum flask, and also know the definition for hot heat and the effects and the sources of hot heat. That's basically what you have to know. Now we move to temperature. We know that temperature is, you know this from your elementary. Uh, Temperature is, oh, typing errors, Allah. Okay, temperature is the degree, temperature of a substance is or the degree of hotness or coldness of that substance. Okay, the degree of hotness or coldness of that substance. And the unit of measurement of temperature is degrees Celsius, Kelvin, or degrees of Fahrenheit. Degrees Celsius, Kelvin, or degrees of Fahrenheit. Okay. Now let's move quickly to thermometers. Let's look at this, then we'll end it for today. When we talk about thermometers, they are instruments used to measure the temperature of a body. Okay, instruments used to measure the temperature of a body. We call them thermometers. And thermometers have, every thermometer has a liquid inside the capillary tube. Is that liquid that you see that you use to determine whether, let's say, it's hot 30 degrees Celsius, 40 degrees Celsius, or hot 50 degrees Celsius? Is that liquid helps you to determine the temperature of our body? So that liquid inside hot the temperature, the thermometer, we call that liquid hot thermometric hot substance. Thermometric substance. Okay, that thermometric substance can be mercury, it can be alcohol, etc., or any liquid at all. Okay, that will be used by the manufacturer. So we have, so I defined the thermometer. I say it's an instrument used in measuring the temperature of the body. And I said the liquid inside the thermometer, we call them hot thermometric substance. They help to determine the temperature of the body. And that liquid inside expands or contracts. Let's say if you are using this thermometer to determine, this is my thermometer to determine the temperature of my body, what happens is that when my body is of a higher temperature, is having a higher temperature, what happens is that the liquid inside will expand. But when my body is having a lower temperature, the liquid inside will contract, it decreases. So that's basically the thermometric hot substance is. And we have the types, and we have the liquid in glass thermometer. We have the gas thermometers, the resistance thermometers, the bimetallic thermometers. We have the thermoelectric thermometers and the pyrometers.